Hi, Chris Guzmal here, and now we're going to be talking about hypothetical reasoning. And let's begin with a little bit of intuition. What if Dasha cried at the window when I left? Why, that would mean that she loved me. Does Dasha love me? Usually we can infer from this that when we see Dasha crying at the window when I leave, then indeed she loves me. But she's just a cat. We are interested in a proof that captures this intuitive idea, and that is embodied in a structured proof. A structured proof is just like any other proof, where it begins, and then there's a proof within a proof, and that's indented to the right, and often we'll put a vertical line over here as well. We don't see that in this outline, the structure of a structured proof. Then after the structured proof's subproof is done, then the main proof ends using the results of the subproof. And so, what does a proof overall do? It starts with some premise or assumption, and it follows rules of inference to reach some conclusion, meaning that we've proven that the premise implies the conclusion. So we can kind of produce a logical sentence out of any given proof. So if we put a proof inside of a proof, what we're doing is we're making it possible to produce a particular kind of logical sentence. And so a structured proof starts with a premise, and then it will have an inner assumption and do inner reasoning. This just means reasoning and an assumption and reasoning that happens inside our proof. And then there's a conclusion that I will call an inner conclusion. Then that inner assumption implies the inner conclusion. And that's what we are then able to use after we've completed the inner proof. We then use reasoning using that implication, and then we come to a conclusion. That is the structure of a structured proof in a little bit more detail. Now, here's a structured proof example, the simplest structured proof I can think of. We start off with the premise Q, and then we proceed with an assumption P, and we have a vertical bar next to it, which supports our indentation idea. Then we reiterate Q, and so now we have an assumption P and a conclusion Q, and then we can thus say P implies Q. And we can use implication introduction, which is a rule of inference which we're actually kind of using before we define it. We could have used, in this case, implication creation. We could have put anything in front of the implication operator for Q. And that's true. This approach also accomplishes much the same thing. And that assumption can be anything at all. So we might have a proof that starts off with a premise, then we assume not P, and then we reiterate P, and we conclude that not P implies P. And this seems very counterintuitive. How can we have not P entail P? Remember, we assumed we had the premise P. And so actually this proof here might be usable as a subproof if we ever need to have it be the case to show that P implies that not P implies P.